Alright, so we're starting 6.7. We're modeling with exponential and logarithmic functions. In this first video, we are going to be given data, and we need to determine the type of function that is represented by each table. So, to do this, actually, let me put a piece of paper behind it so I can write on this. To do this, we're going to look for changes here. If I just look at the x values, I can see that each time, to me, it looks like it's adding 1. Okay, all the way across. Now, for the bottom here, since that's going all the way across, this also needs to go all the way across. So, those are all plus 1s. I'm not going to keep writing it. But down here, I need to look at what happens. So, it's going from 0.5 to 1 to 2, 4, 8, 16, 32. Looks to me like each time, if I multiply 0.5 by 2, I get 1, times 2, I get 2, times 2, I get 4. Looks to me like all the way across, I am multiplying by 2. Okay, so we have some ways to, or things that will help. I want you to take a little bit of note here. So it's going to be a polynomial if you're adding each time. It's going to be an exponential if you're multiplying each time. Okay, so in this case, I multiplied every term by 2, so it has what's called a common ratio, and that would be 2 over 1, which is 2. Okay, because it has that common ratio, it's multiplying each time. We know this is an exponential function. Alright, so let's look at the data in the second table here. Alright, well, if I look at the top here, I want to look at their changes. Looks to me like I'm adding 2, I add 2, I add 2, all the way across. Okay? And then I need to look at these changes. Now, doesn't to me look like I multiply by anything, because to get 2 to a 0, I'd have to multiply by 0, and then that'd make everything 0. So it's not multiplying. So let's just start with adding, subtracting, that kind of thing. So if I have 2 plus something that gets me 0, I think that's a minus 2. 2 minus 2 is 0. 0 plus 2 is 2. 2 plus 4 is 8. I'm sorry, 2 plus 6, hello. 8 plus 10 is 18. 18 plus 14 is 32. And 32 plus 18 is 50. Alright, well, none of those are the same. So if these were the same, this is called the first difference. Oops, and I'm off from page, you can't see that. The first difference, if those were the same, this would be linear. Okay, but they're not. So that's not going to work. Let's keep going. Let me get a different color here. Let's find the difference of these differences. So negative 2 to get to 4, or I'm sorry, to get to 2, I just said the answer. I add 4. 2 plus 4 is 6. 6 plus 4 gives me the 10. 10 plus 4 is 14. 14 plus 4 is 18. So this is called the second difference. This was the second time we found the difference. Okay? When that's the case, it's a quadratic. Notice the pattern. So like if we kept going, okay, so this is like x to the first, x to the second, okay? So we know right here what type, because this is all 4s, what type of function we have. We know these change at a constant rate. The second difference changes at a constant rate. So this makes this a quadratic function. Whoops. Alright. So I'm going to stop this video here, move on to the next video to find out how to find an equation based on data of an exponential model.